In lesson 4, we're going to be talking about percent change and percent error. So we're going to be talking about two new proportions today. Your learning target is I can solve percent change and percent error using a proportion. If you need a minute to write this down, go ahead and pause the video. So percent change and percent error have to do with what it sounds like, change and error. So we're going to see problems where different things changed or increased, decreased, what was the change, and then we're going to see percent error, which is talking about by how things were off by. So quick thing we just need to go over is something we've discussed a little bit before is decimals to fractions, but decimals to percents are also a thing. So decimals and percents are essentially the same thing, just written in different forms. So one is written in a decimal, one is written in a percent. What I mean by that is if I write 1/2 as a fraction or 0.5, you would hopefully know those are the exact same thing. One is just written in fraction form and one is written in decimal form. So the same thing applies to decimals and percents. So when you have something written in percent form, as in 24%, that is the same thing as 0.24. So 24% is the same thing as the decimal 0.24. Same thing as 70% is the same thing as the decimal 0.70 or just 0.7. You can have the 0, you don't have to. I'm moving the decimal over, think of it, 2 places. So 42% is the same thing as 0.42. Now on your own, you should be able to know, okay, what is 72% as a decimal? And hopefully you're saying 0.72. Now if we're going to go the other way, like here we have the decimal 0.94, that is the same thing as 94%. 0.85 is the same thing as 85%. 0.6. Now, some of you are maybe thinking, oh, that's the same thing as 6%. It is not. 6% would be 0.06. 0.6 is 60%. Same thing with 0.1. 0.1 is 10%. If you were looking for 1%, it would be 0.01. And this one is kind of confusing. I don't know why there's a second decimal right there. But 0.72 is the same thing as 72%. Now, we will practice this some more when I am back. So just something I wanted to introduce to you. But for the most part, today we are talking about percent change and percent error. So when we're talking about percent change, when we do our proportion, as you know, 100 always goes on the bottom. Percent always goes on top. On the left side, change goes on the top. And that'll make sense when we do the problem. But for now, you're just going to write change. And the bottom, something we've talked about, is the before. Go ahead and pause this and write this down on your cheat sheet. So write this proportion down on that cheat sheet. The percent change proportion is in the second row. And then we're going to talk about percent error. The percent error is also the change over the correct amount with percent and 100 over here. Again, pause it, write it down on your cheat sheet. Percent error, you're actually going to have to write in. There's an empty box on the bottom right-hand side of your sheet. You're going to have to write that in today. So pause this, get these written down, and then when you're ready to start again, we will start doing our examples. We're going to go through 8 examples today. So the first one says, Austin estimates the weight of his dog to be 18 pounds. So he doesn't know that his dog is 18 pounds. He's just estimating that it's 18 pounds. However, he finds out the actual weight of his dog is 25 pounds. We need to find the percent error. So we want to know by how much was he off by. So when we set up our proportion, we know that the change goes on top, or the difference. So he thought it was going to be 18 pounds. It actually was 25 pounds. The difference, or the change between 18 and 25, if I were to subtract them, would be 7. And then the bottom is going to be the correct amount. And so the actual weight of his dog is 25 pounds. So then I can go ahead and multiply. 7 times 100 divided by 25, and we get 28%. So he had an error of 28%. That's pretty high. Okay, he was off by 28%. Pretty high. We'll talk about tomorrow what a good and what a bad percent error is. Today we're just going to find it. All right, the second one talks about a basketball player who averages 26.8 points per game last game, and then 25.6 games this year. 25.6 points per game. Add that in. This year. Find the change. So we talked about percent change. On top, change. So the difference between 26.8 and 25.6, you are just subtracting the two. And 26.8 minus 25.6 is going to give you 1.2, so that's going on top. And then the bottom is the before amount. So last year, 26.8, 100 over here. Do 1.2 times 100 divided by 26.8. And I get a super long decimal. It says round to the nearest tenth. So my decimal that I got was 4.4776. If I want to round to the nearest tenth, I want this number. So I look at its neighbor, and its neighbor is going to tell me to round up to 4.5%. So he changed by 4.5%. All right, flip it over to example 3 on the back. So Sean estimated that the attendance at a college lacrosse game was going to be 3,000. However, the actual attendance ended up being 3,200. We want to find the percent error. So when we are doing percent error, the top is going to be the change. So the change from 3,000 to 3,296, you're subtracting them. And you get 296. And then the bottom for percent error is the correct amount. So the correct amount, the actual amount of people in attendance, was 3,296. And then I do 296 times 100 divided by 3,296. And again, I get a pretty long decimal, 8.98058. It says round to the nearest whole number. So that's the number in front of the decimal. I look at its neighbor, it tells me to go up. So you should get 9%. Example 4 talks about the specification of the length for a bolt is 4.75. So that's how big or how long the bolt should be. But a machinist, so that's someone who makes bolts, makes a bolt that is 4.769 inches long. What is the percent error? So on top is the change. So remember to find the change. You're subtracting the two. So I can do 4.769 minus 4.75, and I get 0.019. The bottom is the correct amount, or the actual amount, which is 4.75. 100 on the bottom. Multiply by 100, divide by 4.75, and you get 9.025%. Now, if we're going to round this to the nearest tenth, we would just get 9%. So he was off by 9%. And again, tomorrow we'll talk about more what that means to be off by 9%. All right, we've got about 4 left. If you want, you can kind of pause it, do the problem on your own, and then see if you get it right by replaying the video, just to kind of get the answer and test out what you know. All right, example 5 says, a student estimated that the school was going to serve 420 lunches that day. However, it actually ended up serving 480 lunches that day. So, in order to solve this, you're going to put the change on top. So the change from 420 to 480 is 60. And the actual amount, or the correct amount, on bottom. So they actually served 480. 100 on the bottom, go ahead and solve. 60 times 100 divided by 480. And you get 12.5%. However, it says round to the nearest whole number. So the whole number is in front of the decimal, so you should get 13%. 3 left. Example 6 says a store sold 150 t-shirts in July and 180 t-shirts in August. Find the percent increase in the sales. So we're looking for the change, the percent change. So the change, they did sell 150, then they sold 180, so the change was 30. I'm just subtracting the 2. The bottom is going to be the before amount. So July was the before, that came first. So 150 on the bottom. 30 times 100 divided by 150, and you get 20%. The hardest part with this lesson is probably figuring out if your bottom number is the correct amount or the before amount. So just make sure that you are looking for if you are trying to find percent error or if you're trying to find percent change. So in example 7, we're talking about a runner who predicted that her 5K race time would be 24 minutes, but her actual time was 25.3 minutes. So we are looking for the percent error. So percent error, the change is going to go on top. So the change from 24 to 25.3, subtract them, is 1.3. And the bottom, when we're doing percent error, is the correct amount. So what she actually got, which was 25.3. 100 on the bottom. Do 100 times 1.3 divided by 25.3. And you get a long decimal, 5.138339. It says to round to the nearest whole number. Whole number is the number in front of the decimal. We look at its neighbor, and you should get 5%. And the last one, example 8, says the price of a video game decreased from $60 to $45. Find the percent decrease or the percent change. So the change, the difference from 60 to 45 is 15. The bottom is the before amount. So it started at 60. That was before it went to 45. So you're doing 15 times 100 divided by 60 and getting 25%. Go back and rewatch any of these if you need to. Otherwise, this is your lesson for lesson 4. Then you can flip your paper over and start working on the homework, page 15 and 16.